Okay, folks, so I ended the last video and I said I'm going to replace this relay with this. This is IoTrelay.com. So basically an easier way than having to splice wires and everything yourself. Although I highly doubt, I have no idea, but I highly doubt there's solid state relays in here. We'll find out in a minute once I get it hooked up, and we'll see if it's clicky. So this is actually going to be pretty easy, right? From what I can tell here is we just need to pull out the solid state relay, take the two wires that are coming off our XB. We can put them in there, and we should be able to plug in devices. I assume some of these are normally open, normally closed, and hopefully, I think maybe this one here is I don't know if you can even see this, but hopefully this one here is just always on, and then we could power our XB radio from that one. So I'm going to take this apart. I'm going to get this out of the box, and we'll see how it works. Okay, folks. So I've switched it out, and we can turn this on. It's pretty easy. This green terminal block actually slides right out, so it's really easy to hook up the again DIO 0 and ground is all I'm running to that. Now this is normally off, so I would expect that we don't have our lamp, and I just hooked up a little LED here, LED lamp, AC. So these are both normally off, so I'm going to assume this one's on, and then this one's always on. So when I set the state of DIO 0 to high, I would expect that this one's going to go off and these two are going to come on. So let's see here. So we want to set it to high. So we'll send, and as soon as we do, you'll notice the light goes off, and if we're plugged into these two, either one of these, the light is going to be on. And I don't know if you could hear, I don't know if, and we shut that off. I don't know if you could hear, but you can hear the clicking. So they're obviously not solid state relays like the one that we looked at in the other video, or the very beginning of this video. So what is the goal for this video now? What I'm going to do is I'm going to remove the XB altogether. Right? There's enough. I have enough videos and everything else. If you want to figure out how to put distance between your IoT server and this, you can use the XBs, right? And you can watch all the videos, and there's plenty of information there to do it. But what I thought I would do is this. What if there's somebody that just has a Raspberry Pi, and they either have, a device like this IoT relay or the solid state relay that we looked at first. What if that's all you have, and you want to just plug that directly into the Raspberry Pi and then create a small app to monitor the state of, in this case, a lamp, and to toggle the state of that lamp. So what I thought I would do is I'm going to remove this. I'm going to get this hooked up to a Raspberry Pi. I'll put the Raspberry Pi here, and then we'll go and we'll pull down code from my Git repo and just plow through it until we can get that code working to do this. And I'm hoping it doesn't take me too long since I wrote it. We'll see how it goes though. All right, so I'm going to pause this a second. I'm now going to yank this out. I'm going to connect this directly up to a Pi, and we'll have some fun. Okay, folks. So I have my Raspberry Pi set up here. So let me make sure that you can see it. Not that there's a heck of a lot to see. I'm actually have the Pi plugged into the always on outlet on the relay switch here, and then I have ground going to ground in the terminal block, and then GPIO 17 going to positive, and I've got the lamp plugged into the normally off. Remember, there are two of those and one normally on. So first things first, let's just do a little test. So let's make a directory test and cd test, and we'll do an npm init -y to accept all the defaults. We'll do an npm install of on-off, and on-off is the library, the npm library we're going to use for Node to drive the state of our pins. There's others. You can use whatever you want. All right, we're not done. I jumped the gun a little bit. I guess I could have paused while it was doing this stuff. Sorry. All right, so we can clear that. So now, let's go into Node. All right, so now we can, let's create an instance of the GPIO equals require, and it's on-off dot GPIO. All right. And then we can do const pin relay, whatever you want to call it, equals new GPIO. We'll pass in the pin number and out. And now we should just be able to do pin dot write sync. And if we set the pin to high, our light comes on. And if we set the pin to low, obviously it goes off. All right, so not overly exciting, but we do know that we can now drive this this relay from our Raspberry Pi. The last thing we just need to do is build a little Express app, and we can then drive it for fun from a website. Okay, folks. So I'm not sure exactly where I left off, but I'm pretty sure we ran some test code to be able to make sure that we could toggle this IoT relay, and it's by digital loggers, with our Pi. And now we want a little website that we can do it. So then we can do it from our phone or something like that. And just remember, up here on the top left, right, we're normally on, meaning that if we're not sending any volts to the device, that then this is on. This one's always on, and then these are normally off. So right now you see I have light coming in from the left, and we're plugged in here. I also have a light coming in from the right, which isn't on, and it's plugged in down at the bottom, and these are both the same, and that's what we expect, right? We're not sending any power here from the Pi to the device, so we're on, and these are both off. But if we toggle that, then the two lights will switch. So let's run our server, and then we'll look at the code. So it's app2.js. Okay. So if we go to the website here, and then this is, if we look at this view image, so this is that the same device, right? So this is the one here that's normally on, always on, and then normally off would be those two. Would be those two down there. We'll look at this website here in a second. So here's our page, and right now, right, it's telling us that pin 17 is 0, right, meaning it's 0 volts, and that makes sense, right? So the pin that's normally on, or the outlet that's normally on, this one is now on, and we have light coming in. That makes sense. This one's always on. I hope so, because we have our Pi plugged into that, and then these two are normally off, and they are in the off state. And again, I don't have any light coming in from the right. But if I switch these, so now what I did was I set the pin, right, coming in. So I set the pin that we're connected to on the Arduino to the Raspberry Pi, not the Arduino, sorry, to high, which did what? Well, it set this normally on to off, and it set these normally offs to on. Why? Because the pin state is now 1. If the pin state is 0, then this one's on, and then these are off, right? And voila. Now, one thing you're going to want to defend against is this, right? You've got something on, and you reboot your server. So we come in, and at this point here, right, we're on, meaning we have light coming in here. These are on. This one here is off. So you'll see what happened, right? As soon as we reboot the server, that pin goes to low, meaning that right, these went off and then this comes on. So make sure you understand what's happening there, and you can also use things like transistors to defend against a quick spike on a pin and such. But in this case, just realize what's happening with all of these pins. The last thing you would want to do is have your server reboot and open your garage doors or something like that. I'll tell you what I do is I tend to have multiple relays. So each of my garage door has a relay which is just a lock, so it relays just for the power. We have to turn that on with a password, and then we have another relay which quickly toggles the switch to open the door, and we have to do that with a password too. So that way, one, we don't accidentally have the doors open, and two, it makes it a lot more difficult for somebody to open one of the doors. Let's see here. Okay, so that's that. Let's look at the code. So we'll come down to, here we go. Oops, it's down here. So what I did was to kind of continue on. I ended up making an app 2 and an index 2. App was the original one. So here we had a remote Arduino, and we had XBs communicating between our Pi and our Arduino. Here we did the same thing, but instead of just toggling a pin, which we did in this one, we sent some data back and forth for the state of a NeoPixel, right, a hex triplet. And then here's the third one, and this is really the simplest, because all you really need for this is a Raspberry Pi and and something to actuate, and it really could just be an LED to do a test and make sure you can get the website. Remember, we're using Socket.io to keep state between our front and back ends. But I mean, obviously, if you have, a relay switch or something like this, this IoT relay, it's a lot more fun because now you're toggling, an AC appliance or something like that. Let's look at app here. I didn't change too much, but here all we're doing is we're just toggling the state of the relay pin. Right, so I added a relay pin in this, and we did this at the very beginning. We just did a command line version of it. This I'm just logging out at the beginning as I was doing some debugging, so I really don't need that. And that's it. All right, let's jump over to index 2. And I decided to go old school. I used a table. Yeah, IDs can't be a number, so I just put O and then the number for like outlet 1. And every time we get an update, all we do is just do a quick toggle of the state. So that's it. There's not too much exciting going on there. Hopefully you'll make this a heck of a lot prettier. All right.